Okay, guys, I thought I would work through the homework and the notes of what we did the other day. And so I'm going to go out and, wow, we have a suppose that I didn't even notice that was here to begin with. Would you look at that? Love it when I notice that on a video. All right, but this is f of g of x. So you're wanting to calculate the cost of the air conditioner for your Florida home on a particular summer day. The cost for the cool air will depend on the average daily temperature, and the temperature will depend on the day of the year. So there are two relationships are connected. The cost depends on the temperature, and the temperature on the day. So in other words, it's f of g of x, where f would be the cost for the temperature, or the cost depends on the temperature. It would be the temperature, and then the g of x would be the temperature of the day. So you're doing a composition of those functions, and this is just showing you how they can be written. There's two different ways. F of g of x is how to pronounce both ones. So domain restrictions are when you have to restrict a domain on the functions, and I cover that more in 2.8, so you may want to look at 2.8. All right, I will talk about that actually right here because it applies. So given that f of x is equal to x squared and g of x is 1 over x minus 4, I have to state here that x for x is not equal to 4 because that would create a 0 in the domain. All right, so when I go to find h of x, I want to find f of g of x, which is right here. It's telling you how it's defined. So that means I'm going to go to the x, which is x squared. It is something squared. Then I take g of x and plug into that 1 over x minus 4. And then I need to simplify this. So this being squared, I would square the top and the bottom. So that would still give me 1 over x minus 4 squared, where 4, x is not equal to 4. Okay? Now, the fact that this is this way, I could understand if multiple choice is given and this is not there. Do realize that you can multiply this out. I'm just trying to figure out where I'm going to write that. I'll just write it up here. 1 over x squared minus 8x plus 16. If you don't know where that came from, take the time and box it, foil it, get it figured out. Okay? What's the domain? Well, the domain is all real numbers except x equals -4, or could you write it? You could write it negative infinity to 4 union with 4 to infinity. In C, it says find h of 6. Well, there's two ways to do this. I've done it one way where since this is f of g of 6, and I just wrote x as pretty as you please, 6, since that's what it is, you can take g of 6, plug it in, get a half, then find f of a half, plug it in, and get 1/4. Or you can use this equation that we had to begin with, 1 over x minus 4 squared. Plug in your 6. It's 1 over 6 minus 4 squared, which is 1 over 2 squared, 1 over 4. I get the same answer. It doesn't matter to me which way you do it. I tell you both ways, so you have two options. Okay, in this picture, we have g of x here, f of x here. Please always look for what you're given. Okay, so that's our g of x. This is our f of x. So pay attention to that because you can't do these without it. Now, I have all of this worked out, and if you don't need to know what we did on all of this, feel free to fast forward because this video is probably long. All right, probably will be long, we'll see. All right, so f of 2, so this says for x equals 3. Well, if x equals 3, find the f of g of x. Now, in this one, I have to go to g of x first and let x be 3. So I'm going to find g of 3. G of 3 is 2, so I put 2 right here, and then I'm going to go find f of 2. Well, on 2, it's -6, final answer. Okay? Now, this is using that x is still 3, so g of f of 3 means that I'm going to find the f of 3 first, which is 1. So g of 1 is equal to, go to 1, it's at -2. There's my answer. Would you say that it matters the direction that you did it? When one gave me -6, the other gave me -2? I would say most definitely. Okay, so this is not the commutative property. It doesn't work. One way isn't the same as the other, so be very careful with that. All right, so for x equals 2, find the value of f of g of x. I went in and found g of x is 0 at the value 2, 1, 2. It's kind of hard to see, but the original document will probably help you. You can zoom in on that if need be. So that is 0. So when I do g of 2 is 0, I plug f of 0 in, and I get 4. If I have 2 times g of f of x, when x is -1, I go to f first, and -1, I get a 0 here. So this is the 0. Plug in for g. All of this became 0, and it might help to have some lid. That is 0. So 2 times, well, f of 0 is -4. Here's f of 0. It's down here on -4. So 2 times -4 will give me -8, and I'm done. On the last one, do it yourself, then check your answer. I got -3. All right? Okay, looking at the back. Example 3, describe the transformations of the composition of functions. So, describe it. G of x is x minus 1, and I'm going to embed it into this function that is squared. I believe, oh, this is wanting to know how the transformation's affecting it. Oh, I did this wrong. I wonder if you did this at first thought. All right, let's fix that. That's okay. So this is affecting what's on the inside of it. It's not going on outside, so that's not a y change. This is an x change, because look at your x going from here to here. This is involved in x, so this will be going right 1. Right 1. Done. This one, f of h, I'm having to plug in, instead of having x squared, I am multiplying the x by 2. So this means it is a horizontal dilation of not 2, but a half. Dilation of 1/2. Why is it 1/2? Because this 2 is grouped with an x. It's not on the outside, so it is the opposite of. It's 1/2. The opposite in multiplying is dividing, so it divides by 2. Okay, now when we do g of f of x, this one's a little different. We take the x squared, and we're going to subtract 1. So it took this function and subtracted 1. So this is actually going to move down 1. Okay? All right. So example 4. Now this one took me a little bit of time, and watching her video on AP Classroom, this example is included in that, and you may just want to slow down and see it. If not, here's my answers if you can read them. If not, go and see hers. I will tell you what it said. Give the equation that models the height of the water as a function of time. Where do we know that? We know that right here. It's 0.08 times t, because it's 0.08 feet per hour. So you would multiply that depending on how many hours it's doing. It's running, it's going 0.08 feet. All right, so 0.08 t. That came from here. Now, using v equals 225 pi times h, identify the meaning of this. Okay, so h of t is the water's height as a function of time. So V of H is the water's volume as a function of height. So V of H of T is equal to the water's volume as a function of time. So it's how much time it takes for this pool to fill up. All right, decomposition of functions. I am going to tell you, this took me a minute to wrap my head around, and I think I was missing a few things in here to start with. So notice our functions over here. Here's h of x, and it has combined these two functions. Now, I'm going to tell you, I will be the last one to figure out what these two combine to look like. It's going to take me a minute. In fact, it would probably take me a graphing calculator minute to just plug them in and see what happens. But let's talk about this. So given that we have h of x is equal to a composition of functions of f of g of x, decompose h of x by identifying a valid f. Okay, so first of all, this tells me what it is when it's finished, my h of x. But what in the world, where could this have come from? That's going to take a minute to figure out, and we have to be creative. So what we're going to do is we're going to say, I could take this, I could take e to the x and raise it to a third power. There's something raised to a third power. Now, why did I say that? Because a power to a power is multiplied. It could look like this, or it could look like this. So be aware that it could be either one. We have e to the x to the third power. So that, the way it was written gives me the hint that I had something to the third power. E to the x is what I had to the third power. So when I come over here, I would say, this gives me, I would start with, and if you're wondering, does it matter which one goes first? Yes, it does. So I want to raise this guy to the third power, which is what this is saying in the original, right here, right here. So I would say this is being embedded in the third power. So this is my g of x. Hold the phone. If I have this to the third, it's going to plug e to the x into that. I think this could be beneficial either way. So the e to the x part is my f of x. I made this f of x, and I made x to the third. I made that g of x to go last. So I said this was f of g of x. That means I'm going to have to work a little harder to figure out these bottom ones. Okay, not easy. All right, so if we have f of g of x gives us this plus 1, I have to go down here, 1, 2, and 3. What's going to give me, okay, so this could be to a third power, or it could be x to the 3 to an x squared power. So I have 1 and b. By the way, a was a typo. It was supposed to say x squared plus 1. So if I square this function, I want f of g of x. I want to put this inside of this x. Would you see that if I change that x to an x squared, it's going to look just like that? So I am going to use these two to create this function. So this would be e to the 3x. What goes inside of here? X squared, which, whoops, that had a plus 1 on the end. It's going to give me this exactly. So I need 1 and b to make that. On this one, f of g of x, look at what I have. I have a 2 plus 3. So that means I must have had a e to the 3x and an e to the 2x. Oh, I see what happened. Okay, so 3 and a. I need these to combine because my g of x, taking this, is going to put it inside of this. So this is e to the 3 of x squared plus 1. And that will give me, oh, wait a minute. If I do it that way, putting that in, that's going to give me 3x. That doesn't give me a 2 plus 1. I had 3 and a down for that one. It'd give me a 3x squared plus 3. Oh, that's exactly what it has. 3x squared. You have to distribute this. It's exactly what's going on. And then on this one, it's f of g of x. That left me 3. Wait a minute, I can't use 3 again. It would have been 2 in C. It's 2 in C, not 3 in C. Let me fix that while we're here. Sorry, guys. A 2 and a C. All right, so it's these two going together. Now, some of these are examples in the notes on AP Classroom, so I suggest go back and double check those. All of this is not on AP Classroom. All right, so composition of functions. Let f be this, g be that, and h of t be this. I've got 3 things. Find a rule for each of the following. State the domain of each composition. Okay, so I've got to remember to state the domain. So f of g of x. Guys, you know I'm dyslexic. I cannot stand to look at it like that. It just makes me so happier to see it embedded like this. So I'm going to take f, which is x squared minus 3x. Do you see every time I said x, I made a parentheses? So I used this and created this. Now, g is what goes into it. So this piece, 1 over x plus 2, 1 over x plus 2. This is going to give me, wow, 1 over x plus 2 squared. I'm going to see if I feel like reducing that. Minus 3 over x plus 2. I'm just wondering if I'm supposed to find a common denominator on this. I've been doing so much of that and other things that I feel like I need a common denominator. I can tell you that x cannot be negative 2. The domain will be, I can tell you the domain, it'll be from negative infinity until 2 and 2 to infinity, union 2 to infinity and beyond. Okay, sorry. All right, that takes care, and it's not 2, it's negative 2. I lied. Negative, negative. There's my domain. I took care of the last one. If we want this simplified, we have to get a common denominator. I would have to multiply by x plus 2 over x plus 2, which is 1 minus 3x minus 6 all over x plus 2 squared. And final answer, I think this is reduced plenty. Negative 3x minus 5 all over x plus 2 squared. So f of g of x. Okay? And x cannot be negative 2 because it put a 0 down there. G of f of x is equal to g of f of x, because it makes my brain happy. I'm going to do g first, 1 over x plus 2. I need x squared minus 3x in here, which simply gives me 1 over x squared minus 3x plus 2. Now my domain, I don't know what it is until I factor this. So I have to factor this first, which isn't that hard to do. X minus 2, x minus 1. So I can tell you that x is not allowed to be 2 or 1. All right? So my domain, wow, that's just the answer. And I don't care if you have it this way or factored form. That doesn't matter to me. But I do have to say the domain is going to be negative infinity until it gets to 1, union with 1 to 2, union with 2 to infinity, and I ran out of place, but I've squeezed it in there. Got it. Okay, so separating these to make me happy. All right, f of h, going f first, x squared minus 3 times x, h is the square root of x, the square root of x. This is just going to become x minus 3 root x. So that is my final answer. I don't have to do anything to simplify that. I just have to limit the domain. And the only thing that's going to cause problems is this guy. He can't be negative. So x is greater than or equal to 0 is the domain. It's my restriction and the domain. Okay, on this one, h of, okay, so it starts with h, so I've got to take the square root of whatever x is. I got to plug in x squared minus 3x. Okay, guys, this is finished. It does not break down any. I can't take the square root of x squared because this is an add-in problem. I can't factor out an x squared. So this is done. However, the domain is going to be driven by the fact that this is a square root. So x squared minus 3x has got to be greater than or equal to 0. If I factor out the x, and I set this equal to 0, x has to be greater than or equal to 0. It's not allowed to be negative or 0. Actually, it could be 0. It'd be fine. Just kidding. Or x minus 3 is greater than or equal to 0. So if that's the case, I just thought, you know what? If they were both negative, it would be okay. Either they're both positive or they're both negative. If they're both positive, greater than or equal to 0, x is greater than or equal to negative 3. If they were both negative, so would 0 to 3 work? Oh, that's positive 3. Just kidding. X is greater than positive 3. I'm going to have to graph that to see what it looks like. I think that this is going to create a situation where, oh, if this can never be negative, this will always be positive. So, oh, this is good between 0 and 3. Because 3 times 3 is 9, and 3 squared is 9. 9 minus 9 is 0. Ooh, you got to hear my thoughts. Oh, that was scary, wasn't it? Okay, so this is good from 0 to 3. 0 is less than or equal to x, which is less than or equal to 3. There's the domain. Whoa, what? Yeah, it's magic. Okay, so the graph of the function is given along with a table for g of x and f of x. So here's f of x, g of x. H of x looks like it's this function, a verbal description of k of x. Here's k of x is a quadratic function with a horizontal translation of 2. Horizontal translation of 2 means in the x direction, so negative 2 goes right there, followed by a vertical translation of negative 3, so minus 3 goes there. All right, there's our function. All right, find f of g of 5. Okay, so I'm going to go ahead and find g of 5 because I think it's easier this way. So g of 5 will give me negative 2. And then f of negative 2, here's my f, here's negative 2, it's equal to 2. Here it is. It's worth 2. Done. That's kind of cool. These are kind of fun, guys. Okay, h of f of 8. I'm going to find f of 8 first, which is negative 1, and then h of negative 1. Negative 1, this is going to give me my negative 1. It's the absolute value of negative 7 plus 3 times negative 1. So this is negative 3 minus 3 is negative 10, which is 10. All right, got that one. K of 0 is equal to K of 0, plugging in a 0 here. I'm sorry, I really want to see this as x minus 2 squared minus 3. That's just so much better. K of x equals. All right, so plugging in a 0 gives me negative 2 squared, which is 4. 4 minus 3 is 1. And then g of 1. I don't know what g of 1 is. Did I mess up? That's 4 minus 3. Quadratic function with a horizontal translation of 2. For it to go, wait a minute, it didn't tell me right or left. It says a horizontal translation of 2. Well, if that doesn't work, what if it were positive 2 and we plug in it? It wouldn't matter. It's still going to give me 1. I don't think we can do this one. There must be a typo in it. No solution. Oh, what am I saying? It is possible to have a no solution. So since 1 does not exist here, okay, 1 is not up here, there's no solution. The end. All right, h of 1. Sorry. All right, I know this is like entertainment. Don't have pizza and have everybody watching me. I'll cry. All right, h of 1. 1 is right here. It's negative 4. And then g of negative 4 is pi. Done? And then f of 2, if I go over here and I plug in f of 2, I get 1. And then f of 1, boop, gives me 4. How'd you like that? You got some sound effect. All right, g of 7 is, where's g? It's here. 7 is 4. And h of 4, I don't like the h's. Oh, it's just negative 4. Done. All right, find f of g of 5 and g of f of 5. Does this confirm or deny the validity of the community property for a composition of functions? Explain. Okay, so if we have f of g of 5, I need g of 5 first. G of 5 is negative 2, and f of negative 2 is equal to, here's f of negative 2, it gives me 2. And g of f of 5 gives me, wait, f of 5, no value here, no value here. Folks, we are at there's no solution here, because I can't find an f of 5. That's an open dot. It doesn't have an answer. I'm kind of glad that happened while we're on this video together, because now you can see you can't finish it. These community property does not work. Commutative property Does, which means you can change the order of things. Does not, well, I wanted to say does not work. That means it really does not work. So it does not work when f of g of 5 has an answer and g of f of 5 does not exist. Okay. Oh my word, there's more. Okay, number 3. This video is getting long. A ship traveling 20 miles per hour parallel to a straight shoreline. The ship is 5 miles from shore and it passes a lighthouse at noon. Draw a picture of the diagram, represent the problem. Okay, this may go way south and I may stop this video. I don't know. Draw a picture. Here is a ship. There we go. All right. Traveling parallel to the shoreline. He is going 20 miles per hour. And my husband's calling. I've got to stop the video. Sorry.